It was philosopher Thomas Carlyle who said, "Teach a parrot the term supply and demand, and you've got an economist." In this lesson, we're going to describe the slopes of the supply and demand curves, and we're going to find points of equilibrium. All to answer the question, how do manufacturers decide the quantity of a product they will produce? Before we get into it, let's make sure we're ready for this lesson by looking at warm-up number 2. Determine the sign of the slope of the graph of each equation. This means it would be very helpful to turn them into y is equal to mx plus b form. So y is 3 minus 4 over 3x. That's a minus 4 over 3, so it is a negative slope. On the second one, if we divide everything by 3, we get y is 4 over 3x minus 3, and that is a positive slope. Now on this one, we're going to wind up with 3y is 9 minus 4x, simply by moving that 4x to the other side. This looks just like A, which means we're going to have a negative slope. Now let's take a look at a problem you will be able to do by the end of this lesson. A company wants to base the price of its product on demand for the product, as well as on expenses. It takes a poll of several of its current retailers to find out how many widgets they would buy if at different wholesale prices. The results are shown in the table. The company wants to use linear regression to create a demand function. What is the equation of the demand function, and round the slope and y-intercept to the nearest hundredth? Now you can use a linear regression feature on a graphing calculator to find the equation. We have also done this previously in this course and have a spreadsheet for it. So that's what I did. I went to the spreadsheet, I put in all of the x values, all of the y values, so that it can spit this answer out to me. So that we get Q is negative 1. Q is 1756.19p plus 30,238.82. This represents the demand function. Economists often call a new unnamed product a widget when they're discussing business strategy. When a business develops a new widget, the number they need to manufacture is a key question they need to address. Graphs may be used to help answer this question. Such graphs compare the price of the item P and the quantity sold Q. The horizontal axis is labeled P and the vertical axis is labeled Q. The set of P values on the horizontal axis is the domain, and the set of Q values on the vertical axis is the range. Graphs using the P and Q axis can be used to model a trend in consumer interest in a product. A demand function relates the quantity of a product to its price. If a widget has a low price, many people may want it and will be able to afford it, so a large quantity may be sold. If a widget has a high price, fewer widgets will be sold. As the price increases, demand, the quantity consumers want, is likely to decrease. As the price decreases, demand increases. The graph of the demand function is a negative slope. However, its curvature varies as shown in these 3 demand curves. Graphs using P and Q axes can also be used to model a trend in manufacturing a product. Producers provide supply, the quantity of items available to be sold. If a widget sells for a high price, the manufacturer may be willing to produce many items to maximize profit. If the widget sells for a lower price, the manufacturer may produce less. As prices increase, supply increases. The graph of the supply function has a positive slope. Its curvature also varies. Economists' decisions require research and knowledge of the law of supply and demand. To explore the supply and demand, graph both functions on the same axis. Examine what happens as the manufacturer sets different prices. Keep in mind that the manufacturer usually sells the item to retailers, such as stores, and not directly to the general public. The price the manufacturer charges the retailer is the wholesale price. Retailers increase the price amount called markup so the retailer can make a profit. The price the retailer sells the item to the public for is called the retail price. How does all this help determine the price of a widget? Well, look at these three graphs. Look at the graph on the left. If the retail price is set at $3, consumers will demand H widgets, and manufacturers will be willing to supply K widgets. There will be a shortage of widgets. High demand and low supply often create a rise in price. Manufacturers know that people want widgets, yet there are not enough of them. If the price rises, demand will fall. Look at the center graph. If the price is set at $7, consumers will demand K widgets, and manufacturers are willing to supply H widgets. There will be too much supply, and manufacturers will have to lower the price to try to sell the high inventory of widgets. Look at the graph on the right. At the price of $6, the number of widgets demanded by consumers is equal to the number of widgets manufacturers will supply. Where the function of supply and demand intersect, the market is in equilibrium. Supply depends on the expenses involved in producing a widget and the price for which it can be sold. The factors of supply are going to be outlined in the next lesson. This section concentrates on demand. The Wacky Widget Company sells widgets for $2 each wholesale. A local store has a markup of $1.59. What is the retail price? Well, we need to add the markup to the wholesale price, which means we need to take $2 and add $1.59 to that to get $3.59 as the retail price. Let's check our understanding. A wholesale price of an item is X dollars and the retail R dollars. Express the markup algebraically. Well, we know from the last one that the retail price was equal to the wholesale price plus the markup. But here we want to find what the markup is, which means retail minus wholesale is going to be equal to our markup. But it did tell us X is the dollars, so R minus X will be our markup. The Robear Corporation sells teddy bears at a wholesale price of $23. If a store marks this up 110%, what is the retail price? Now, to compute the markup, then calculate the retail price. First, we need to convert the percentage of markup to a decimal, and 110% is 1.1. So we're going to take that 1.1 of the price, $23, and get $25.30. Now, the wholesale price and the markup price are going to give us our retail. So we know our markup, we add in the wholesale price, and we get $48.30. So it retails for $48.30. Let's check our understanding. A banner company sells 5-foot banners to retailers for X dollars. The St. James sign shop marks them up 90%. Express the retail price at St. James store algebraically. Well, we know we're going to pay the X dollars that is the item. And we're going to pay 90% or a 0.9 of that as the markup in order to get its retail price. This means we're going to pay 1.9 times the wholesale price X. Now, let's find the points of equilibrium. The graph shows the supply and demand curves for a widget with a price set at $11. Explain what happens if the price is set at $9. Because $9 is less than the equilibrium price, demand will exceed supply. Suppliers will attempt to sell the widget at a higher price. Let's check our understanding of this. Use the graph to explain what happens if the price is set at $15. Supply will exceed demand. Suppliers will attempt to sell the excess widgets by lowering the price. A company wants to base the price of its product on demand for the product, as well as on expenses. It takes a poll of several of its current retailers to find out how many widgets they would buy if at different wholesale prices. The results are shown in the table. The company wants to use linear regression to create a demand function. What is the equation of the demand function? And round the slope and y-intercept to the nearest hundredth. Now you can use a linear regression feature on a graphing calculator to find the equation. We have also done this previously in this course and have a spreadsheet for it. So that's what I did. I went to the spreadsheet, I put in all of the x values, all of the y values, so that it can spit this answer out to me. So that we get Q is negative 1. Q is 1756.19 p plus 30,238.82. This represents the demand function. Let's check our understanding. Explain why it makes sense that the demand function is a negative slope. Well, as the price increases, a smaller quantity is demanded. So the demand function slopes downward. This is indicated by a negative slope.